my boxing gloves on.
Let's kick it off because, like you said, there's a lot of people that are either on Kubernetes or moving to Kubernetes, and data is a bit of a question mark. So we are having a round two because Patrick and I spoke, what was it, in July or yeah, July. It feels like that, and quarantine time feels like a lot longer than that. But we were able to talk about this question of, is Kubernetes even ready for data? And so today we decided to bring along another smart person. We've got Patrick's expertise, and we've also brought along Jeffrey to the ball game, or to this round two. And what we want to do is explore this idea more, because there are people, I think we should just go out and say it right now, that the quintessential messiah of Kubernetes, Kelsey Hightower, is screaming from the mountaintops that we shouldn't be doing state on Kubernetes. But as I've talked to more and more people, there's a lot of people that are doing it and they're able to do it well. There are just a few snags that you have to be aware of. And so what I wanted to do today is really explore this, because if we just listen to Kelsey Hightower, then we would all have to figure out some other way, right? And we wouldn't have advanced this conversation at all. But now we've been able to advance it. We've seen that there are some really cool things happening, and I want to explore that today. I want to go deeper into it. And so we'll use some of the stuff that we talked about those many moons ago with Patrick and I, and we're going to introduce new ideas and new topics, of course. So that is my spiel. I think we should just start maybe by surveying and getting like a pulse check from Jeffrey and Patrick. And Patrick, has being the returning champ, maybe you can go first on it, of what I'm talking about with this, like, there's people that are saying we shouldn't do stateful and we shouldn't be running data on Kubernetes. And how do you feel about that? I know that you had some strong opinions the last time we talked, so I'd love to get where you're at right now.
Yeah, it's funny because I've been talking to Kelsey too, and he's very much against it. But I think he's also thinking in terms of cloud native is about composability, and thinking of stateful workloads almost as like shoving a square peg into a round hole. You're like, if you're gonna just take your bulk version of your stateful workload and just try to shoehorn it into Kubernetes, yeah, I agree, that's a pretty bad idea. So what's been happening? There's a project we're looking at, like the Apache Cassandra project. We're looking at like, okay, what is it that, sometimes it's not all about like, no Kubernetes, get it together. It's like, you come on, man, we're here with our thing that's just perfect. It's not that. It's like, I think there's a real interest in making changes to like a database like Cassandra, because it's a Dynamo based system, and Dynamo was built with this idea of commodity backends and connecting those. The Dynamo model is way more about how you create distributed systems and consistent data than a specific implementation. And so I think that it will change quite a bit over time. Cassandra is, we're getting ready to ship 4.0 here shortly. If you haven't seen all the hype, it's amazing. But 4.0, post 4.0, I think you're going to see a lot of head scratching. It's like, not even that. It's going to be a lot of movement around making changes to Cassandra that will fit the deployment model. And the reason I say that is, it's not because, it's, well, we're just going to try to follow the hype train. It's this massive. We found that 60% of the Cassandra deployments are in shops that are also heavily Kubernetes. But they're not running Cassandra in Kubernetes. So that's and it's only growing.
Yeah.
So this is paying attention. It's not just following along with the, doing their thing. Yeah. So it's a different energy for sure. But it's like what do we compose? What do we bring in the composability? You know, so Jeffrey and I, we actually just talked last week about this. You're like, what do you bring to the party? Yeah, coincidentally, the conversations are pretty intense. Next week at KubeCon, you're going to see a lot more of that, I'm sure.
Mm-hmm.
Yeah, so yeah, actually, a couple of things I would like to touch upon. So first of all, there is no such thing as stateless, right? Because I mean, from a computer perspective, and probably not having a state could be considered a state as well if you really want to get into the weeds. But I think the differentiation is that there might be state that you do not necessarily care about. And that means that you can either regenerate it, typically with CI/CD pipelines, for example, so you can compile the source code again into the binary artifacts, or the ramifications are not all that big. So let's say that I'm shopping on Amazon and I'm clicking together something, and the site crashes, or the backend that I'm routed to crashes. And the worst thing that can happen is that I need to reread my cookies, which is stateful, or I have to put my shopping bag all the way from scratch, which is not that big of a deal, really. So I think that there's always state, just what state do you care about? And I think that when you look at cloud native applications, these type of things are important to consider. And the other thing Patrick mentioned was composability, and that to me indeed is key with storage, and because there should really be no reason to manage your storage any different than you manage an application through Kubernetes. If you would argue that storage is just another application when it comes to what it does with the bits and bytes. And sure, eventually there is this device that stores the data, but other than that, for the most part, it's software, I would say. And so the trick is going to be trying to find composability such that individual developers can, through declarative intent, make clear what they expect from the persistent layer, whatever that is, and give them the flexibility to decide what is best for that particular workload. And I think that with OpenEBS, that's well, we try several things, but one of the things that I try to sometimes or at least try to explain, is that if you look at what Kubernetes tries to do, is abstract away the underlying compute and just have the developer focus on deploying the application. With OpenEBS, we try to do the same for storage, where we abstract away the underlying storage and where the developer just can focus on the PVC, if you will. So, and in terms of, is it ready? I think it is, but I do feel that it's not for the faint of heart, I would say, because how you twist and turn it, Kubernetes is it gets getting used to, let's put it like that, and storage doesn't necessarily make that easier. So picking the right software, picking the right community, I guess is probably fundamental when you make these type of choices.
So big words coming hot out the gates, Jeffrey, saying there's no such thing as stateless.
Yeah, no, absolutely not. It doesn't exist. It's
and then I like the reverse what is it, the reverse psychology on it. Like, yeah, it's ready, but not unless you got some cojones.
Yeah, well, I mean,
I was going to say it's not stateless so much as it's ephemeral. I like to use the word ephemeral more just for my cloud background. When we say stateless, sure, there's a component to that, especially with web servers, like, things come and go. But ephemeral is probably a better way of describing it, meaning, it can just disappear and that's okay. We can regenerate it. Databases aren't quite that way.
Right, but nonetheless, it is a certain form of state. You don't necessarily have a disaster if you lose it, but yeah. So indeed, and if you look, for example, in particular, so I have some experience with Cassandra, and I think it's been a while, but I think it was version 3 or something like that. But if you, for example, look at composability, right? Let's say that you want to deploy Cassandra through Kubernetes, and one of the things that Cassandra has done very well, and I'm not actually sure if they had that before Kubernetes. I would be I would not be surprised if they
Since
actually
day
did.
one.
Yes, but
Yes.
the topology awareness, right? That is baked very deeply inside Cassandra. But even though that when you configure Cassandra, you have several options, and you can configure it very complex, you configure it very simple, but there is this thing of storage that you need to consider. So for example, you have different types of data that Cassandra generates. And you could argue that if you want to have the commit log on a faster device within Kubernetes, you need to somehow, some way tell the system that, hey, Cassandra, I would like to have my data on this type of PVC and my commit log on this type of PVC. And so you need to have that composability regardless. And I think that providing the abstraction at compute and storage, I don't necessarily think that you can do without. You have to have it, or you don't necessarily have to have it, but you would paint yourself in a corner rather quickly if you don't. And then there are, I've been in situations where people had Cassandra systems and they were pretty happy with it. And although that they understand and fully grok the fact that Cassandra can handle data replication very well, they still wanted to, for certain cases, use a rate set underneath the data that Cassandra stored. And well, if you want to do that just to sleep easier at night, there should be a way for you to express that when you compose the PVCs for the Cassandra deployment that you put in the cluster. So I think composability.
Well, yeah, the typical RAID set configuration is more for speed, like whenever you have a bunch of crappy disks, you want to do like a RAID 1.
Right.
And
Yeah.
so yeah, that's actually been a really strong guidance for like if you're running spinning disk, because that's how you keep up latency and throughput whenever you have a 7200 RPM disk underneath.
Yeah, these things are DoK slow, right? So yeah, exactly. And the but talking about speed, which is another thing to consider, and I think that if you look at modern day computer systems and what I think that cloud native or cloud native deployments or new applications, however you want to phrase it, I think the upside there is you have the opportunity to get rid of a whole lot of legacy. So for example, we just said, slow RPM drives. These days you can get huge NVMe SSDs, for example, with a high capacity, which are relatively cheap. And some argue that they're better for the environment as well. So you probably can get some funding for that as well. But if you look at how those devices are built, you also would need to rethink how you saturate these devices, because if you just grab your database that you created, I don't know, several years ago and just put an NVMe device underneath and expect things to go faster, it will to a certain extent, but you won't max it out because the hardware changes are so big that it requires certain software changes. And you can see these things happening with I think Cassandra was in Java, if I'm not mistaken. So this, what's it called? Neo, New IO for Java. It's this native interface because it's a VM, so it doesn't have direct hardware access, and this allows it to do it. But in any case, they use this new kernel subsystem IOU ring, and the performance of the same application, but just using it differently, increased 300%, right? Just by changing the way that you submit the IO to the system through the whole software stack. So all these things combined really require you to rethink, how you can get the biggest bang of the out of your buck, if you will, from a hardware perspective, and in the end, in cloud native environments, that translates to costs, which you guys will be talking about next week, if I recall correctly, right? So less is more when it comes to that. And if it's faster, then it's like, okay, well, does it really matter that I need to rebuild a terabyte of data? Well, if it's a slow device, then yes. If it's a super fast device and you can do point-to-point RDMA access between the devices, probably not, right? So there are a lot of things to consider when you build these new cloud native applications, and yeah, composability for sure. That's how I started. Is very, very important, I think.
Very good. We're starting with a very, very strong quote from Jeffrey that will be remembered for a long time of there is no such thing as stateless. Now, moving it over to a very famous quote from Patrick, slightly different, but let's see what we can get out of this. Patrick famously said, "Friends don't let friends shard."
Yeah,
Patrick, I don't know if that was from 2020 or if this predates this conversation, but maybe you can fill us in a little bit about that, and then let's see where we can take this.
Yeah, no, I mean, sharding your database. Come on, I did that in what 2005, and that was cool then. I did a talk on that. It was cool. 2008, it was uncool. So yeah, moving on. Sharding databases makes me sad because you just started putting all kinds of weird application logic in your database at the weirdest layer, which is the middle layer. And if you've ever worked with sharded databases, then you realize quickly that you're building technical debt so fast. It's like a high interest credit card. You're just like, I'm never going to pay this off. So this is actually why I got started with Cassandra in the first place, because I was in this game of sharding MySQL and Oracle databases at such a rate that it was like unsustainable. And I was watching my friends at Facebook trying to figure out how to make it shard. And they were modifying binaries in MySQL to make it work because they couldn't do updates on their database. I'm like, guys, this is stupid. Why are you doing this? And that was in 2008, 2009 that we were starting to talk about NoSQL databases. And like, wait a minute, there's got to be a different way to do this. So getting, trying to glue these topics together, because, this is data on Kubernetes. It's like, that problem is not going to go away. When I see projects in Kubernetes and databases that just make sharding a lot easier, I'm just like, why are you pouring gas on the fire? I mean, you're trying to make this ancient old technology, this clunker come in and look cool. It ain't gonna happen. You got to use use the modern database for the modern deployment tool. If you think that the old thing from 40 years ago is going to work for you, you're going to be really disappointed in 10 years. Trust me, because now it's 50 years old. So that's, I think of like where I help a lot of our people in our community when they realize that they never have to shard their data again, and that they have a database that'll elastically grow and shrink and can scale how they need to without any downtime. It's like a gift. I'm like, here you go. I didn't build it, but I talk about it. There you go. And right now, I think that's where operators are, SREs were with Kubernetes, is when they're seeing like, oh, I could just do a kubectl, grow my cluster, shrink it, and it all kind of works together. Now I could focus on different things, like, my business, because it's really a struggle right now in COVID times. I saw a study that productivity is up like 6% during the pandemic. That's crazy. And it's just because every business is struggling to figure out how to stay valid and online. That's the thing. Digital transformation. Hey, nerds, we kind of won this one. I hate to say like there's winners in a pandemic, but nerds win, because look at everyone in the world is trying to figure out how to go online with everything. New iPhone 12. You see the circle.
Well, I like
that's
I like what you're saying there.
Kind of ranting a little bit there.
Oh,
but
no,
yeah, here we are.
That was a good one. That's a good one.
What I'm wondering about is since we do have a storage guy and a database guy here on the call and in the room, we can say in this virtual space that we've created, one of my go-to questions that has just been coming up over and over again, and it's been put in Slack a few times, is who should control the replication? And Jeffrey kind of pointed to this earlier, and I want to know, maybe Jeffrey, you can start us off with this one, but like, should I replicate both on the storage layer and the database layer? Or should I just leave it to one? What does that look like? And how do I not like over replicate?
Right. Well, I think I don't necessarily think that there's a perfect answer necessarily, because you can replicate for reasons other than availability, right? So it's not to say that people replicate because the database can't keep its act together. Absolutely not. There can be other valid reasons. But typically, however, if you have a database that is good at what it does and allows you to effectively per table define what type of replication you want and whatnot, there is no need to do replication at a storage level because the database does it a lot better, and also has more control over the data itself and can optimize caching and whatnot, what storage can never do, in the sense that it doesn't have context. It just sees a stream of bits and bytes, but it doesn't know what it actually is looking at. So however, if you have such a database and you want to, for example, get some additional speed or redundancy just to avoid the need for rebalancing or things like that, then you might be able to say, okay, well, let me put a simple mirroring or whatever on top of that, or underneath that, just to make things more simple, or to, for example, say this hardware is now out of service. I need to replace it, and you don't necessarily want to, what's the phrase? Well, you don't want to taunt the gods, right? It's like, yeah, it should work, but let me just hot swap the device out. That would be, simpler. So yeah, so there, like I said, so there can be different reasons why you want to do it, but from a data availability aspect, if the database is sound, then you don't necessarily need to do that. But I do feel that the composability is mandatory within Kubernetes. We have, for example, a customer that wants to doesn't want to have replication, but if the machine crashes where the disks are, he wants the ability to pick up the disk, if you will, and move it somewhere else on another node where the application can start. So that's not replication, right? That is composability. So how do you do that? Even though there's no replication, you still want to be able to lift and shift, if you will, the storage to another Kubernetes node where the application can restart. So I hope that answers your question somewhat.
For sure. And I imagine Patrick's also got some thoughts on this. What do you want to say?
Well, what I've always said, if you're thinking about data, your database should be managing the replication, because you're asking for a certain amount of consistency, and the database is the only arbitrator of that. So if you need something you need a guarantee that something is stored on disk or is committed correctly to the database is the one to tell you that. And so that really goes back to the Dynamo database model of like what the original Dynamo paper from 2008. When you talk about consistency of data and replication, it's not about the movement of data. It's about where is my data and is it there? So yeah, I have worked with Cassandra users in the past that have used like really, really expensive like SANs, like these big symmetric multi-million-dollar arrays. I'm like, you don't need to do that. That's like Department of Redundancy department, and the only person happy is your EMC storeman, EMC salesperson.
Yeah, exactly. Yeah.
So and that makes sense when you're running something like Oracle, because you get one. And if that one goes down, you're totally screwed. And so, that's why you want to do that. You want to create this distributed database to avoid that problem. When it comes to, what makes me sad is when I see people using like DBRD to replicate the block storage with Cassandra. And I'm like, you're wasting bits at this point. It's interesting. One of the things that replication is creating, though, is a fascinating way to do backups, and keeping snapshots of data, and that's more of like a regulatory issue right now. That we're shifting the need for this. So financial data, for instance, they need a snapshot in time. Kubernetes is starting to move into regulated entities like financial services. There's questions about, all right, how do we make sure that we have a snapshot in time that shows like some sort of state of our data at a certain moment. And that's when you start getting into like, okay, so then we snapshot our data. That's a certain set of data that needs to be replicated into slower tiered storage. Because I'm not going to pay premium SSD price for data that I'm probably never going to look at ever again until, the regulator shows up and says, can we see that? And I'm like, okay, we'll go figure out how to chip it out of the iceberg, but I think there's, we need to think differently. This is a different place. And when we talk about data on Kubernetes, we get all kinds of new primitives to work with.
Yeah, that's right, and I would agree with that. Although there are other things, for example, that you might want to think about if you have, let's say, a set of nodes and you run out of storage, right? And being able to dynamically grow that without a, let's say, virtualization layer between the actual physical devices and what gets consumed by the database, that would be rather difficult, right? So I think that other than replication, there are more things to consider when it comes to that. Another thing, for example, is, well, I guess in Cassandra it doesn't necessarily matter all that much, but certain databases want to have a form of protection against data corruption, for example. So it depends in various ways. And some databases don't have replication at all, as far as I can tell. So yeah, what do? Well, you probably have to do some form of replication. And to me, replication perhaps is somewhat different than what you guys, I'm talking more about synchronous mirroring. In fact, really, it's like instead of writing it to 1, I write it to 2. That to me is synchronous replication, if you will. So
and with Cassandra, you're going to get that with right out of the coordinator, and you're asking for a certain consistency level. Right. So if you have 3 replicas, you could say I would like a quorum right, and it will return, like, I've committed this data to 51% of the replicas properly, and it won't return that positive until that happens. Which, this is a part of that. The part of Kubernetes that I think is really important is that the resilient self-healing part. That it's just not optional anymore. We need to be able to withstand failure. Power turns off, networks get partitioned, sysadmins turn off things inadvertently. I don't know anyone who did it. I may not have done that ever. Oh, is that a switch? Oh, I turned that off by mistake. My bad.
There's actually
like fat finger a whole cluster reboot. Oops.
Oh man, here's my back in the day story. This is when I was running data centers for a company, and so we had multiple just racks and racks and racks of equipment on all these different data centers back before we were really into cloud. Thank God for cloud. And I, as the boss guy, I show up, I'm going to help them move. We were going to be moving racks of equipment, like entire racks. And they're like, oh, you want to help out? Well, we need to de-energize. We need to pull the power off of these racks over here. Well, I didn't quite get the finger point where he was pointing. And I walked over to the main rack that had like the Cisco routers for the incoming bits. And I went over to the big old 208 volt twist lock and just pulled it out. And like the entire room got quiet and everyone just looked at me and they're like, you just brought us all the way down. And so Can I just put it back in? No. So, that was when I realized it's not all about, just small things. It's the big things when the idiot walks in the data center. As a result, I was never invited back into that data center, but network partitions are real, yo.
Yeah, they have been. And we don't need to point any fingers.
No. Actually, at that point, all my evaluations were a good job of keeping it online because I can't.
Yeah. Well, so there's a few things that I want to talk about off of that, like the tail end of that. And one is, the importance of chaos engineering and what is coming out. I know, Jeffrey, you're doing cool stuff with Litmus chaos. There's stuff going on there, and the importance of just what you're talking about, Patrick, like turning it off on purpose and seeing, does it still work? Because it's no longer a nice to have, it's table stakes, right? And so that whole resilience and the ability to go through these power outages or these people turning things off. But really what comes to mind that I really want to ask about is the idea of databases that were around before Kubernetes. And now, Patrick, you alluded to this, like you can't just shoehorn a database into Kubernetes because that's what we've been trying to do and it's not working that well. And so we need to go and we need to start thinking about things in the Kubernetes way, we could say, and then get the benefits of Kubernetes. And I remember last time that you were on here, you talked about how the parts that start to come into conflict are when you have are the reasons you need operators, right? Like you start to create operators because, well, Cassandra will deal with its own resilience in its own way, but then Kubernetes also deals with resilience in its own way. And then those two, as our friend Paul put it, it's like two ambulances rushing to the scene of a crime or the scene of an accident, and they can't see each other. And they just end up running into each other and creating another accident, right? So this idea of creating like Kubernetes style databases is something I want to dive into. And also the idea of people want choices. And so like the loosely coupled idea, and this is where Jeffrey, I wanted you to chime in on this, is because like giving people options, especially with storage and being able to say, well, you can do this, you can do that, you can have many different options because the teams are going to be smaller and they're going to be in this Kubernetes style also. So I'll let you take a stab at that first, Patrick. And it wasn't necessarily a question. It's more of just a theme that I'd like to dive into.
Yeah, well, that was what I alluded to earlier is, we're, as a project, the Cassandra project is full of, chock full of really good distributed systems engineers, which is a great thing. And they're not just super zealous about one database. They're thinking about like, how do we do distributed systems properly? Kubernetes being one of them. When I talk about composability, I think of the three parts of any distributed application, which is network, compute, and storage, which is ironically exactly what every cloud will sell you. That's really only what they want to sell you is network, compute, and storage. Everything else is to get you to use more network, compute, and storage. And that's what the breakdowns are. And, it's interesting because that's what Jeffrey and I were talking about last week is, there's every part, if you focus on every part and think about it in composable terms, like how are we going to make these work together? You can think of things instead of just one tarball to deploy. Like Cassandra is not just an executable. Thinking about it in terms of like, here's different parts that need to be put together. We've started going down this route on the project. And I think this is going to be a progression that we do over time. The Dynamo model is actually the one thing that makes the most sense because it is built kind of cloud. The Dynamo model, of course, and I keep throwing out the Dynamo thing, but Dynamo DB paper was written, the Dynamo paper was written by a group of engineers at Amazon in 2008. A lot of people think that's where Dynamo DB came from. Nope, just name collision. But the Dynamo paper was around this idea of how do we distribute a database that is consistent and can be replicated and resilient. And it had to do with each node is shared nothing. And how do you manage that through the different bits of computer science? And if you look at that paper, it's an artful paper. There's 24 papers cited inside of that go into things like how to manage quorum data, how to replicate, how to manage consistency in those kind of situations, how to manage failure. And what we have is this availability. There's this CAP theorem, consistency, availability, and partition. Most databases up to that point were CP, consistency, and CP databases, where it's all about the consistency. And if you can't manage the consistency, then you don't do it. Sorry, shut down. You just don't let any more things happen. The Dynamo model changed everything to AP. It was on availability and partition tolerance. So you can have like two data centers that don't see each other and still be able to do live reads and writes, and that they'll rectify the data once they're connected together. So there were several databases that went that route: React, Cassandra, Voldemort, which is a really cool name. There's another one called Dynamite, which is hilarious. But there was a lot of databases that went that route. Cassandra is the one that's really kind of has survived and moved forward. But that model is valid in a Kubernetes world, because look at, like, when you do a deployment and you create all the parts, you're creating the ingress, the networking component, you're creating the nodes, which is the compute component, and then you're creating the storage, which is, that's the storage component, obviously. So I think this is where we are, is like, okay, this is the next level. And that's where when we bring in the people who can focus on those really interesting things, like what Jeffrey was talking about with storage, it's like, PVCs are a hot mess. I think we could do better. I tend to agree.
Jeffrey, just really quickly, we got a question from a community member, Miguel, who wants to know, because a topic that comes up a lot for us, whether it's any element or area with this whole Kubernetes realm, is how to avoid vendor lock-in and talking about multi-cloud environments. And so Miguel's question is: are there solutions to run databases in a multi-cloud federated manner?
Well, if they're the same database within a different cloud provider, I would argue that that would be possible. But that depends a little bit on cloud is the new proprietary, right? So if you walk into the Amazon candy store, you get bombarded with all kinds of cool features that work straight out of the gate, and before you know it, you're stuck and you can't go back. So that's dangerous. But if you have a database that is good enough to run at multiple clouds, and you can set up the networking and the VPNs and all the security and whatnot, then I think that would be possible. But I think it's also fair to say that there is no single database that serves all type of workloads, right? You have different types of data, you have different requirements of certain data. So you again come towards this composability aspect where you might want to favor one database over the other because it's specifically built to handle time series data, for example, or whatever it is, right? And sometimes there are performance requirements that come into play where you need, I don't know, 1 million IOPS from a disk perspective to achieve that. And so when you look at the how things are evolving, one of the things that make databases very much in the early design phase of the database itself, which will dominate where it will be good at, is the way that they handle the things like compaction, consistency, and type of stuff like that from at the disk layer. And so as you have different choices and different types of databases, they optimize for particular types of data and things like that. But when you look at the NVMe space, for example, what you see happening now is this key value store SSDs, where instead of having the software do all the hard work in trying to not emulate, that would be a wrong word, but implement key value types, you can do that with the NVMe devices straight away. And that gives the opportunity for the database vendors to optimize again for what a database is really all about, and that is indexing, searching, and things like that, right? So I think that, again, the composability is key, and you typically find different types of databases, as you guys mentioned, that you have smaller teams, and it is not realistic to say that a two-man pizza team that need to provide, I don't know, specific service that they will by default use database XYZ because it has whatever. type of features, right? It's like it's going to be a mixture of all kind of things, and the idea typically is that the developer knows best what he or she needs from a storage layer, from a data consistency aspect. We briefly touched on the CAP theorem, so it really depends, and that's why you can't make a system that does everything very well. You should to give the tools to build a system that allows you to solve your problem very well, but not necessarily dictate like this is all things to all men, and walk away, because that just doesn't work. I think
That's a great point, and we may have to make a quote out of that one.
Oh, that's two quotes already. I need to get
or a T-shirt.
Or a T-shirt. Yeah. We need a friends don't let friends shard T-shirt. I think that's gonna be patent pending.
Actually, I have that on a Cassandra shirt. It's an old one. We did a contest, and somebody like, that's the shirt we need. Is like I'm not sure if that was the exact quote, but it was something along the line of friends don't let friends shard. Yeah. Oh no, scaling doesn't have to be shard.
Okay.
Oh.
There you go.
So that might be the next iteration. And for those that are just listening and they're not actually watching, Bart has replaced his
no
Mexican ponchos.
Complimented my
He's complimented his Mexican
Don't worry.
poncho with some Data on Kubernetes shirts and swag that we've got. So as we mentioned in the beginning, if you want some, reach out to us on the Slack and we'll send you some your way, because that's how we do swag these days. It's like that. You can't come by a booth, but you get to talk to us on Slack. So now, Jeffrey, I mean, you're making some great points. I just wanted you to tack on a little bit of that idea of the options and how teams are really, like, I know there's a lot of talk about loosely coupled teams and how the ability of choosing where you want your storage to be, like, and how you want to do your storage, just how you look at that.
Yeah, well, I think this isn't necessarily just related to storage per se. Obviously, I work on storage related products, but I think one of the key things between these systems are so big and so complex that it is impossible to comprehend the whole thing at a high level. I mean, and this is not even true necessarily for distributed system. If you look at the most well-known monolithic piece of software, the Linux kernel, it's like they have lieutenants or captains, whatever they call themselves, for each individual subsystem, and he or she is responsible for that. And there's the circle of trust, right? And if you look at how software in cloud native environments is built, it's typically the same. You have a task that you need to do, and you provide an interface, and you provide a certain SLA, or you're deemed to provide a certain SLA for that particular service. So I think one of the fundamental things is that you need to have clear interface boundaries and well-documented interface boundaries and well-tested interface boundaries. And without those interface boundaries, you cannot create an operator in Kubernetes. It will just create more pandemonium in the system. It doesn't help. You need to have consistent and valid tested interfaces. And then on top of that, you can basically build whatever you want. And if the interface is abstracted properly, you can flip the engine mid-flight as long as the interface stays the same and provides the same contract. You're good to go. And that's very simply said, obviously, but far more difficult to do, of course, because all kinds of implications are just hand waved away. But it's one of the patterns I see somewhere, or at least in the Netherlands. And I won't say that we're really good at IT necessarily, but strangler patterns are used a lot, where they try to roam off an old database, but they don't really know what data is in there or who uses it. But let's encapsulate it with the service, make a tight service such that we can track what goes in and out. And after 3 years, we'll just turn off the switch, and if nobody screams, it's okay, right? It's like these systems are acquired by acquisitions and whatnot, and it's like, how do you fix that mess, and how can you maintain these new GDPR rules and whatnot if you don't even know what type of data is in there to begin with, right? It's not like you invented it. You came in, it breaks in your lap and you have to deal with it. So yeah, I think that's key, right? So small things, observable things, testable things, and clear interface boundaries between them and contracts, if you will. And if you do that, then you should be able to jump in any DevOps shop and say, okay, what do you need from me? This is what is there a particular demand, like a deadline? It's always going to be, yeah, fast, right? But how fast depends. And I think that's key. And what the actual individual developer does to uphold to the agreement you made should be completely irrelevant. Obviously, there are some governing rules like data governing and whatnot, but other than that, it's your show, man. As long as it works, I don't care.
All right. Patrick, I listened to a podcast earlier from Sam Ramji, the Chief Strategy Officer at Datastax, and he was talking about how he likes to personify Cassandra as a woman, and so referring to her that way. If we talk about Cassandra as a woman, or as a person, I guess I should say, as a human being, what are the conditions that will be necessary for Cassandra to get on Kubernetes? What is it going to need to be taken? What kind of openness?
Or are you bridging that together? That's really cool.
Well, no, I got really inspired listening to that because he was on the Google for Kubernetes podcast, and when he was talking about that, I was thinking about, like, if we're putting it in that sense, what are the necessary conditions in terms of openness and readiness that are going to get Cassandra well functioning on Kubernetes?
Yeah, well, I mean, first of all, Cassandra being a great mythological character is fraught with tons of baggage. Cassandra was the oracle that no one believed. It's like, good mascot.
But she was right. But she was right.
But she was right. Yeah, that's the thing. Actually, there was kind of a tongue-in-cheek. There's a little backstory. There's a tongue-in-cheek joke by Avinash, who was one of the original, he was a founder or original builders of Cassandra, that, it's like, she also foretold the doom of the Oracle. It's a database joke. All right, it's a database dad joke. It's really bad.
And you were an Oracle guy, so you know.
Whoa, man. Yeah, we're just going to wrap that right up. So I think your question, so dad jokes aside, your question is about what is it about Cassandra that's going to make it a Kubernetes database?
Yeah, what are the things that are necessary to get Cassandra ready to be comfortable to be running functionally and openly on Kubernetes?
I'm glad you asked, because we've already started that process by modularizing. So we use in the Cassandra project, we use these things called CEPs, Cassandra Enhancement Process. And they're just how we propose new large scale features instead of just dropping a ton of code or opening a Jira and saying, I got a great idea and here's my code. We have more structure around how do we advance the project, like big things that are changing. There are several CEPs, and there will be more coming around building more modularity into the system. As I mentioned, right now is when you deploy Cassandra, you can choose anything you want as long as it's local file system. And that's great. Did you want a local file system? Great, that's the choice. And the storage system is what is built into Cassandra as well. Now, Instagram has kind of taught us a different way, which is thanks not just because they teach us how to do social media, but Instagram has integrated RocksDB with Cassandra in this thing they call Rocksandra. That opened up a lot of doors when people are thinking about how that works. So modularity and storage is one of them. Being able to provide a variety of database or a storage choices below the line. So if you think about, like, again, network, compute, storage. Network is the API layer. Like, how are we going to do this? We've started an open source project called Stargate, which is out there, which is basically abstracting the API layer above the compute side of Cassandra. So Stargate allows for things like REST, GraphQL, gRPC, document, whatever API you want to use to access your Cassandra compute layer. And then in Cassandra project, we're like being able to do pluggable storage. So instead of just using what we call the 8099 engine, which is the only engine you can use, the storage engine you can use in Cassandra, being able to bring your own. So maybe it's something like a RocksDB or something like that. And there are a lot of choices to use. So all of these things, the punchline is that we will be able to use those and compose them in different ways in a system like Kubernetes.
Very, very good. Jeffrey, anything to add to that? Any thoughts, reflections?
Well, I think that there's one thing well, it depends a little bit. I always say that it depends. It's a little bit of annoying, but it is actually really true. But one of the things that is not obviously clear is just like, what is the behavior of the system when resource constraints come into play? And this ties back into Litmus, as you mentioned before, because when you have a new Kubernetes cluster, everything is hunky-dory. But when things start to shape up like at random and badly, it's like, which application gets to suffer first, and how do I control what gets suffered or sacrificed first? And I think that's something that needs to be looked out for. And I think there was this. I'm not sure if it's still the case, but you saw a lot of Kubernetes clusters that had a specific function, right? It's like, this is my Kubernetes cluster that runs Cassandra, and this is my Kubernetes cluster that runs whatever, right? And I think that keeping a system that constantly is able to monitor and advise you to a certain extent about the state of the system and what its breathing room is in terms of network saturation, disk saturation, and CPU saturation and whatnot. Because right now it's only during scheduling. If you have a system that needs to, I don't know, rebalance or do some checksumming or Merkle trees. Cassandra uses Merkle trees, for example. Wow, that's really cool, right? Or at least they used to. I'm not sure if they still do. That's really, really cool, but it's not cheap, right? I mean, you have to do some CPU work, which is fine, but how do you size it out? How do you get the bandwidth correct? And I think, again, the right tooling is important, and validation through Litmus, but it's not all that obvious when you start out deploying your application, like what it will grow into. And that is very difficult to assess. And even so with distributed databases as well, because as you lay out the data in certain table formats, you anticipate the data to be queried in a certain way, but well, it turns out that 2 years down the line, you were wrong, right? It's very difficult. So yeah, I think it's a good thing, because that gives us job security, right? I mean, after all, software engineers should really just make sure that they have a job by adding random bugs and making no code comments, right? It's like, that's how you do it. But yeah, I think I'm diverging a bit, but yeah, because the question was, is like, what is it that you need to have in order to run Cassandra on Kubernetes, right? And I think that obviously storage composability, Cassandra itself, obviously, but then also it's like, what do you do when the kubelet decides to kill your pod or you screwed up your YAML, for example? How do you validate that? And I think that's very, very important to consider as well.
I'll help you with this one, Jeffrey. Is how about some consistent storage, and storage that's better suited for Kubernetes. I think that is one of the things that Evan and I first started talking about with regards to OpenEBS and MayaData was, right now the choices for storage in Kubernetes are kind of bring whatever you got. It had been like, well, just glue in this thing you had laying around and it'll be fine, right? Creating purpose-built Kubernetes version storage is just really important at this point. You should be able to ask for storage with a certain level of quality. And if you're not getting it, then you should not take it. And, you know, up to this point, if you're running your WordPress website on Kubernetes, yeah, storage is kind of like, whatever, you need to store some GIFs, right? That's no big deal. But now that we're getting into like, no, this is like mission critical, totally different game. You need to have that.
Yeah, exactly. Or what about the situation where you have some data somewhere and it wasn't considered mission critical, but all of a sudden it is. It's like, what do you do, right? So yeah, and I think that's key, right? The software is not solving your problem, but the software provides you the tools to think about your problem and to use the software to solve that problem. Yeah, I think composability is key for sure. And I've actually I went to several conferences and you know, all storage people. I wouldn't recommend them necessarily, but then you have these companies like like eBay and Alibaba and you know, like these hyperscalers, right? And they kind of do an interesting model where they do everything differently than we do now, right? So what we're trying to do now, they've done that, you know, not a good idea, move on, right? So this whole notion of put everything and everything will just work fine on the same box, the economics don't work out, right? It's like if you build, if you need storage, it's better to size a box with, I don't know, 1U, 2U with a petabyte of NVMe and 8-core CPU and practically no memory, right? Because you don't need that memory in that storage box because the caching is typically done at the page cache of the operating system where the kernel runs or the application runs. And caching over the network doesn't really make sense. So you see my point? It's like the economics don't work out, and they just scale by like a fixed amount of resources. And if you need more resources, the key trick is to figure out when you would probably need to order some, right? And that's instrumental, being able to grow and then obviously having the right infrastructure. But it's very interesting to see that the hyperscalers have segregated storage where they have very specific clusters handling storage. And I think one of the key things I would like to achieve personally, you know, despite what others may think, but being able to build a storage system just like any other, right? But it's just managed through good old kubectl, and it is not CUDL, it is CTL, just look at that straight. You know, that's the only thing you really need. It's like the universal control plane. And as I started out, storage is just software for the most part. Sure, there is hardware on the media itself, but contains a whole lot of software again as well. So it shouldn't be that difficult. Obviously, networking is a bit of a problem though, but you know, that's a networking problem, not ours.
Yeah. So I have a question on this for the both of you, and I know we're kind of getting a little bit over time, but
it's round two. It's got to be longer than round one.
Yeah, and it seems like we're all clear for another few minutes to do this. Now, as far as, because Jeffrey, you made such a good point where it's like in the beginning, things are really shiny, just like any new toy. It's really nice. You play with it. It's fun. It works. It's all good. And then after a few years, you can't really predict the way that it's going to grow. And so I'm just wondering if you all can share some experiences with us on how to better manage that growth and how to scale in a proper way, or just what are some things that you've seen scaling so that we don't get into a mess like Jeffrey just described. So maybe Patrick, you want to have a first swing at this and then we'll get back to Jeffrey on it.
Well, don't use a database that you have to do a forklift upgrade on, that's for sure. Don't use anything you have to do a forklift upgrade. If you don't know what your scaling is going to be in the future and the answer is going to be export and import into something or have downtime, bad answer. I think another one that is actually, this is more contemporary in the Kubernetes world now. I see a lot of this energy of just throw an autoscaler on everything, put it on automatic. Oh, that is, and I get it. It's like, oh, I don't get woke up in the middle of the night because my database is overloaded or my web servers are crashing. Web servers can do that pretty well because it's, it's fairly stateless. I'll say fairly, but I mean, it's just like you throw that up and it handles the load as long as you have it elastic in that regard, but put limits on it. But I've talked to folks about like, how do I put an autoscaler with Cassandra? I'm like, that is just a bad idea. And I've done that before in like an Amazon with an autoscale group, ASG. But what you wind up seeing is, and this is not what you want, is you want to manage your workloads more effectively. So this is where you get into observability. If you're not managing a workload by making sure you know what's happening, you get into this really a bad thing can start happening. You start growing your cluster automatically. So you'll wake up in the morning, go to work and show up, and all of a sudden you have 50 new clusters in your database because you got DDoSed overnight. And instead of getting alerted and stopping the traffic at the router or something like that, there's this law of unintended consequences. So so there's been discussion in our groups about like, should we add an autoscaler to the Cassandra operator? And I'm vehemently against that right now.
Very interesting. And
so
Jeffrey,
I kind of went down the anti-pattern route there.
That's all good. I expect nothing less from you.
All right.
Yeah, it's a very difficult question, and I think one of the key aspects is that you need to have a system that is observable, and in a dynamic sense. So dynamic instrumentation. I see a lot of the REST calls that give status and some statistics, but 99% of the time they don't give you the statistics that you need when you actually have a problem, because when you were writing the software, you didn't anticipate the problem, and if you would have, you would not have a problem to begin with, right? So you need to be able to dynamic instrument the system, and then you need to have the ability to do something about that. And in terms of storage capacity, which is relatively simple and easy to reason about, but it's not just the capacity. The sizing aspect is not just capacity, it's also the CPU needs to have enough bandwidth to saturate the storage systems and whatnot. So being able to get an early warning about the issues at play to the person that is responsible for it is very important. And I think also another thing that personally annoys me a bit, to be honest with you, is the sheer amount of analytics that applications produce, or basically, I don't know what I'm doing, just log it to the console, right? And then you need to have this whole infrastructure that analyzes that data. I really don't get it. I would rather like it to be more like a diagnosed problem, right? It's like the software says, I have a problem. This is what has happened. This is the reason why it has happened. This is what you should do to solve it, right? That's useful information. Just spewing something to the console that you have an error doesn't help.
We're going to have a discussion on AI apps here shortly. I can feel it.
Oh, well, yeah, well, it's like artificial intelligence. Yeah, maybe, it's more like, it's like, think about it a little bit more. But so being able to observe the environment and then be able to do something about it. And I think one of the things that a lot of people don't think about when they start to deploy PVCs is they don't give a split second about what file system they are using, because it is absolutely important what type of file system you use. And most people will use the default, whatever that is, right? But it can paint you in a corner rather quickly, because some file systems don't allow you to grow the file system online, for example. Which brings me to another thing, is like the file system. Do you actually need a file system? And you see certain environments where they try to shoehorn legacy infrastructure, which is older than I am, into a cloud native environment, and then expect it to work, and then want to go through Kubernetes and things like that. But it's like a recipe for disaster, really, if you ask me. If you need like legacy file share protocols, I won't name them, and you try to put that in a environment where you have multiple root users, let's say, you get into this ID mapping problem, right? It's like, so what do? Well, you open it up for everybody. Basically, everybody has access to this, export. And then the problems start, because then you cannot reason about security, and then you get into file locking issues and whatnot, and opportunistic locking. So that's another thing to consider, is pick the right type of storage that you need. So it's block, object, and if you really must, then file, but typically I would not necessarily recommend file in cloud native environments at all. And then from a performance tier, typically, it's flash or trash. You either need to be real fast, or it doesn't really matter, right? And typically that doesn't really matter, it goes to the object type like storage systems. But it is important though that you don't pick a distributed object store that can scale infinitely, right? Because then it will take down your whole Kubernetes cluster at one blow. So you do need the abstraction layer on top, where you can move your data left and right, or route it, if you will. Yeah, I'm not sure if I answered the question actually.
I think it's funny that we're here talking about what we're talking about now. Is like, the problem is it's too easy to scale. Because then you get yourself into trouble. It's like, oh wait, it's like way too much candy in front of kids or something. It's like, now we have a new problem. It's not, we don't have candy, we have too much.
But that's one of the primary motivators that we started the whole OpenEBS project. Is we saw that I had another, nobody has ever printed a t-shirt of that, but I used to say that applications have changed and somebody forgot to tell storage, right? Because the scalability and high availability of your application as a whole, whatever type of layers you have, isn't necessarily dictated by the storage that is underneath. Because it used to be VMware, some storage system, and that storage system had a multi-million-dollar ticket on it, because it can never fail, right? And nobody could touch it, and it was always a battle between the infrastructure management, network management, and storage management. And as these things come together, where you're basically responsible for the whole thing, you see that certain things at storage you don't have to do. For example, let's take Cassandra. Well, we don't have to do the replication. That doesn't mean that we shouldn't do or can't do or help you with other things that make your life easier from a storage management perspective, but we don't have to do that, right? So it opens opportunities in certain cases. I think it's always important to start out with a fresh look, and for sure, don't paint yourself to a corner by putting everything through CSI on a specific system and think it's all handled, because your Kubernetes cluster will just crash like any other application if the storage system that you put it all on is crashing. So
I think that's a great point of this idea that, and this has been echoed many times in meetups when we've talked to people about, like, one of the things that people say is, don't forget to put your toys away. Or another thing is, like, how is it even possible that now we can, there exists such a thing as a $40,000 query, right? Like, this scale that we have, and like you were saying, Patrick, is that we're talking about, it's so easy to scale now. We have to be very conscientious of that. And so I know Bart's got some cool stuff to show us.
I got one question, because it was funny earlier, Jeffrey, you mentioned about how in the Netherlands you don't do IT well. Well, the audience is listening, and we have.
Well, no, I didn't say that. I said necessarily very well.
No, just kidding. That's okay. But one of our good friends in the community, Ari, is from Rotterdam, and so he chimed in. And anyway, but jokingly, he was also here talking about costs. But he kind of had a question for the two of you. But since Patrick, since we asked you previously about the conditions being right for Cassandra to be running on Kubernetes, with having an underlying layer like OpenEBS, what impact does that have on Cassandra for its ability to do exactly that, to run on Kubernetes? That's what I already wanted to ask. And if you can say something nice about Dutch people and their tech level, that would be very helpful too.
Well, I mean, let's see. What am I going to say that nice about Dutch people? Hang on, I gotta work on this. No, I'm kidding. No,
double overtime.
No, I've spent a lot of time in Netherlands. There's a lot of great community members in Cassandra community members. Like ING is one has been such a good community member in Cassandra land. I've done a lot of meetups in Amsterdam. But I think besides holding back large bodies of water, like number 2 is IT in Netherlands. I mean, I have to disagree with Jeffrey. So there you go. So what is OpenEBS going to bring? It's a consistent storage. That's what I was talking about. It has been a tragedy of when you don't know what you got below the storage line. When you say, "Here, create me a persistent volume set," and oh, here's my claim on God knows what, and that's what I really started getting to know OpenEBS. That's where I was learning about is here's a class of storage that I actually need for a database. I think it's really critical. And that's that maturation of Kubernetes where it's not just anything you got, it's bespoke. It's a storage layer for data. Evan, who's, I believe he's a founder or co-founder, Jeffrey will tell me. When I first started talking to him about like, what is it about data on Kubernetes? Well, we need a storage for data on Kubernetes because that is, you can make or break your entire Cassandra life based on storage. That's just the bottom line. So yeah,
There's some truth. That is
that's another T-shirt. That's
Just to come back on the Dutch IT, I think Dijkstra is well known. Tannenbaum is famously well known to set Linus Torvalds straight, right? Because he should have gone for the microkernel approach, which, by the way, nobody talks about that, but I actually think it makes sense to reconsider that with all those multiple cores. And then maybe you guys heard about NixOS, which is a declarative operating system. Takes your anyway.
I feel like you're being super defensive at this point.
But
just like, did you just Google all of that?
Python, probably, if somebody heard about that too. No, but in all seriousness, I think so. But for in the Cassandra case in particular, one of the things that we try to do is make sure that we don't necessarily make decisions for you and give you an opportunity to slice and dice it the way you want. And that's a little bit the gift and the curse, because there are so many ways to do it wrong. But working with guys like Patrick, who know the database inside out, and for example, it became rather clear that based on the traits of the database itself, you probably want to have these type of storage classes, and OpenEBS can provision several types of systems. So I work mostly myself from a day-to-day operation on NVMe related stuff, but guess what? There are a lot of probably more than NVMe right now environments that don't care about that at all, and they need a reliable local storage system that is provisioned through Kubernetes and that then the database can pick up. And so we can do that, and I think that that's one of our strengths, is that we don't force you to take a particular pill that we think is right for everybody.
So I've got one last question, and we're going way over, and I thank everyone that's still with us and the both of you for being great sports about this. But the conversation's too good, and I can't cut it off. I actually have 50 more questions for you all, but we're not going to get through those. So I chose my most important question, or my favorite question that I really want to finish with, because when we spoke the first time, Patrick, we talked about this, and then I tried to make a blog post out of this, but then Google lost it, and so it's been deleted forever, and that's another story. But we talked about operators.
That really happened.
Yeah. Now we're just talking story. But we talked about operators creating technical debt, and the idea of operators maybe not being the best way to go about things. And so I'm wondering how you feel about that still. Is it still something where you're like, yeah, operators, they're not good, but they're what we've got? And I just ask a lot of people, what's the alternative? How can we go about this and make something where there's no operators, or is that just something that we have now and we're never going to get out of it in Kubernetes?
Yeah, well, operators are application middleware for Kubernetes. They're just like, how do we translate our layers? And so when you get to the point where you have a native service inside of Kubernetes, you no longer really need an operator. I think that's your graduation present. So if you look at where I think some projects are going, like there's no operator for Envoy. There's no operator for Istio. It's a primitive, and this is what I've been advocating pretty hard in the Kubernetes project, is we need to have more primitives for data. And yeah, operators, they glue us into the future with the past. But I think that'll be when I come on to DoK and I say, we no longer use an operator in the Cassandra project. That'll just, we can like just pause and drop the mic.
That's when the audience will start clapping.
Oh, damn. That sounds like it's native, cloud native all the way. Yes. Yes, it is.
When I hear operators, I always have to think of this very good series from, I think it was HBO, Chernobyl, where these poor young men were in front of this, operator, and they just had to switch, turn the dial, and boy, that went wrong rather quickly. So I think one of the problems with operators, I think, is that it's another abstraction, and before you know it, you're so far, away from what it actually is that the abstraction comes more true than the actual thing that it tries to abstract. So it is certainly not, the default thing to fix. And I think I mentioned it before, is like, you have to have the good abstractions in place for your application itself, and then sure, you can build an operator on top of it. But I don't think a universal operator for any type of system will work, because if you compare it to a factory, right? Because that's where the operators originally originated from, I suppose, is that every factory is somewhat different, right? And if you're making diapers, it doesn't really help to have an operator that is used to make baby milk, right? Even though that underneath they both use Cassandra, it's like the dimensions are somewhat different. So it's
output is different.
Yeah. I hope so.
And Jeffrey, be careful, because we're making animated videos about metaphors regarding data on Kubernetes, and now we've got milk and diapers. So keep going.
Yeah, well, it shows the story of my life. Yeah, I got one is done with the milk and almost out of the diaper, so top of mind. Yeah.
Wait until you get to car. Yeah, that gets expensive. Diapers are cheap.
Yeah.
But that's enough about me.
Nice. Well, I know that we've had Angel here with us. We started this trend last week, and we have an incredible graphic designer that has been sketching the both of you. And I think there may be a way. Bart, can you share your screen to show us what he's come up with?
I'm going to share my screen right now.
All right. Let's see what he created over the course of this chat.
All right. Can you guys see?
Yeah.
Oh, wow.
Wow.
I gotta say that. Yeah, he's really good. I gotta say
wow.
He's very humble. I gotta say right off the bat that the English isn't his first language, so we had to kind of translate things on the go. We were kind of chatting back and forth. So anyway, I'll put this in the Slack. We'll obviously put it on Twitter. We'll put it on LinkedIn. We think it's just a nice way to sort of try to encapsulate a lot of things that we talked about. Obviously, there are a lot of things that we didn't get to. So I'm pretty confident there's going to be a round 3. There's going to be a round 3 in 2021. We'll have to schedule that as soon as we can, because there was a lot of stuff we didn't get to. But anyway, yeah, it's a way of giving a different flavor to what this community is about connecting people, ideas, sharing things, and building something together. So yeah.
Wow, it's really, really nice.
Yeah, I'm pretty
really
impressed.
Good. Yeah. Wow.
It's like when you're like, see the street artists who they're like, and then it's like, here you go, and it's like this perfect photo. Like, you just did that right in front of me.
I know.
So
there's
good. Like, why are you on the street doing this? Or why are you on a DoK hangout doing this?
You gotta up your game, bro.
Yeah. No, come on. Yeah.
Amazing. Well, I thank you both. I thank all of you for being here with us and talking about this, because this is super useful information that I know I am not the only one that finds a lot of value in this. And I could have gone on for another couple hours. I'm sure that few of us could have, but at some point, all good things must end. And it looks like now is the ending. I really want to give a shout out to everyone that asked questions, and also Angel for this incredible drawing at the end here. So if you want to jump in our community, we'll leave a link to that in the description below if you are listening in the future. And other than that, have a great day, night, wherever you are in the world. We will see you all later.
Thank you guys so much.
Thank you, guys. It was real fun. Thanks.
Perfect.
Bye-bye.
Bye-bye.